Hi all, this is the demonstration of our project FPGA based implementation of advanced encryption standard for cryptographic security. So let's get started. First we open Quartus Prime. Here we have our existing project called AES. We open that. Here on the left side we can see the main code, which is the top file. There we can see the input code which we are using. The input data is 128-bit hexadecimal, which says ECE004, so as to represent EC department and its code. So we start with the synthesis. So at the bottom right, we can see the time taken and the percentage of synthesis that has been complete. So we can see it took like 6 minutes and it has reached 100%. Now we open the pin planner. Here we have entered all the input and output pins that are required for this particular project. The outputs are given to the LEDs and 7-segment displays, and the input pins are defined. So now that is done, we open the schematic. It is the RTL view. Here we can see the entire circuit. Now at the right side, if we drop down and open a particular decryption type, we can see the ones that are present, the different rounds: add round, mix column, shift rows, and subbytes. So this is the add round key. Here is where the XOR operation takes place. So to zoom in, we can see the other rounds, the stages: subbytes, shift rows, and mix columns. So this is the different parts. You can see AES encryption 128, 192, and the 256 bits. So this one again for different type of encryption. So all of them have generated all the necessary blocks for RTL. Now that is done, we'll move on to the implementation. So here we are using the same ECE004. We have configured it to do the encryption for 128-bit key. So you can see that by the glowing LED, which indicates 128-bit is turned on. So for 128-bit, it takes like 10 rounds for it to complete encryption. So the button is pressed 10 times. So you can see that the other LED started glowing at the rightmost end. So that indicates the encryption is complete. Now the decryption is starting. So we got back the data which was input and later on decrypted. So it's again ECE004. That is the successful implementation of our project. Thank you.